So when we start looking at all of the convergence of technology and technological trends and the changes that are going on in society, we often want to know, what's coming next. How do I predict the future? When we start thinking about predicting the future, we kind of have to first understand what we believe in. In other words, how do we believe the future gets created? There's two differing views on this, kind of different ends of a spectrum. One is called technological determinism, and tech determinism says that human beings, as in our nature, build technology, sometimes to solve problems, sometimes to gain knowledge, and that the technology itself drives what future gets created. On the other end of the spectrum is social construction. Now, social construction says that everything we have, knowledge, the processes, the way we live our lives, is created by agreement, by a social construct, by a social agreement between people that says this is how we're going to do things. So in one end, you've got technological determinism, which is popularized by folks like Tom Friedman or Ray Kurzweil, and on the other end we've got social construction, which would be what a lot of folks in maybe Northern Europe might believe, the way we build information systems, because we all agree they need to be built. So first you have to decide what you believe in. Then we have to get a kind of an understanding of what are some of the things that are going on in technology in terms of some of the constraints, or in some cases we call them the laws. The first one, and we've seen a video on this already, is Moore's law. Moore's law says, and there's a couple different versions, but it says computing power at a fixed cost, at a certain cost, doubles every 18 months. That means that the 2 gigahertz chip that's in your computer now, 18 months from now, at the same cost, will no longer be 2, but will be 4 gigahertz. So in 18 months, for the same price, a 4 gigahertz chip is what we would be thinking in terms of. So 18 months from now, a 2 gigahertz chip becomes a 4 gigahertz chip. 18 months after that, a 4 gigahertz chip becomes an 8 gigahertz chip. So in a 36-month or a 3-year period of time, we've gone from a 2 gigahertz chip to an 8 gigahertz chip, and that sort of speed change is driving our industry. We combine that with a notion from a guy named George Gilder, who says that bandwidth is growing 3 times as fast as computing power. Well, that's pretty impressive. So when we start thinking about bandwidth, and this is bandwidth whether it's wired bandwidth or wireless bandwidth, the fact that it is growing faster than the unbelievably fast computing power of Moore's law gives us an idea of how important connectivity is. Metcalfe's law talks about the value of the network. So the more people, and we could also extend this by saying the more processes that are connected to a network, the more valuable it is. So as we start connecting literally everybody in the world, we start thinking that the value of a network almost becomes infinite. We tie into that the very important theorem called Coase's theorem. Ronald Coase was an economist in the early part of the 20th century who created a theory, it was later called a theory, that more or less says that organizations seek the lowest possible transaction costs. Coase's theorem has given rise to brand new parts of legal research. It's been used in economics, been used in political science, and most recently Coase's theorem has been applied to outsourcing, and specifically offshoring, essentially saying and predicting that companies are going to try to seek the lowest transaction costs, in this case of IT. So it just makes sense and was very predictable that we would start offshoring IT. There's not really a law associated with expanding storage capacity, but the price of storage capacity has been dropping by roughly half every 9 months. And we tie this to the notion of disk drives or thumb drives that are getting very, very small and very, very inexpensive. We start coming up with a different way of viewing what we store and what we don't store. For some of us, we store everything. The wireless explosion is something that we keep track of. Now, sometimes we think primarily about wireless in terms of wireless data connections, but this is essentially the notion that all physical interaction, whether it's power or data, wired connections precede wireless connections. So you take a look around your house or your office and look at all the things that have wires, and those are targets for the wireless explosion that's coming. Schumpeter's law of creative destruction, he was an economist that believed that old inefficient companies are replaced by entrepreneurial outsiders with new technologies. In other words, new technologies give small competitors an advantage over old companies if those old companies don't keep up with technological change. This is the reason many large companies have kind of technology innovation centers or groups so that they can stay up with technological changes. Schumpeter more or less he kind of thought that capitalism wasn't going to make it, but that's another part of his research. De Geese is a fellow who, while working at Shell Oil, created or is credited with something called the law of learning, in which he said the only sustainable competitive advantage, and what he really meant was the long-term sustainable competitive advantage, is the ability to learn faster than your competition. In other words, the learning organization predicts the future. Okay. There's other factors that we need to consider. Cycle time reduction is something that's driving IT. Studies show that only 3% of the elapsed time for a corporate process is actually needed to complete that activity. The rest is kind of wasted overhead activity, and is that low-hanging fruit that we sometimes aim at. The peer-to-peer law of distributed computing is the combination of Moore and Gilder, and that essentially says that as we start connecting more and more people, then we start seeing an increase in the sharing of computing between peers in the network. In other words, the network becomes flatter, and we see more cooperative computing.